For today's lesson, we're going to review working with exponents. As you look at question A, be reminded that parentheses are essential when substituting and evaluating your expressions. Make certain that you use parentheses. Question B, you're reminded that functions that are x to the third are going to give you a new curve as you graph each problem. The definition of an exponent requires us to write the base, the number of times that the exponent indicates. So if you ever get stuck on a variable problem, make certain to use the definition. Anything to the power of 0 is 1. If you have a negative exponent, you can rewrite the problem. Negative exponents can be placed either in the denominator or the numerator, depending on where that negative occurs. Properties of exponents. If you multiply like bases, add your exponents. If you have a power to a power, multiply the exponents. You can distribute exponents when you have multiplication, and if you have division, you should subtract your exponents. You can also distribute in a division problem. So let's start with our first problem, number 29. This is actually a tricky one. Notice the 2 is to the first power. The 2, when we simplify, will stay in the numerator. What will move is the y. The y to the third moves to your denominator. So as you look at number 33, consider 5 is to the first power. Do not move it. And when we look at number 37, you can see that the exponent -5 should be moved to your denominator. So that leaves us with x to the fifth, and y squared stays right where it is. We need to fill something in. We will have a 1 in our numerator. 41, we're going to take our exponent that's in your denominator and move it to the numerator. So we have 3d to the third power. The 9 is to the first power, so it stays right where we have it. Use your rules now. So we have 3 to the third power multiplied by that 9, and we also have d to the third. So next you will multiply 9 times 27 times d to the third. Once you've completed that problem, give questions numbers 24 through 36 a try. You're reminded that scientific notation has to always be written in one particular format. You should have some number in the units place. Next will come your decimal. To the right of the decimal, you can have as many numbers as you need. And when you write in scientific notation, use an x times 10 to whatever power you're working with. If you have a positive exponent, think of your numbers as a large number. If you have a negative exponent, then you might want to consider those to be a negative number. As you read question number 1, it says the number of bacteria contained in the human body is how many times greater than the number of genes. So the bacteria is how many times greater than the number of genes. We're going to take the bacteria and divide by the number of genes. So 1 times 10 to the 12th divided by 4 times 10 to the 4th. In order to do such a problem, 1 divided by 4 is 0.25. Then you subtract your exponents, so we'll have times 10 to the 8th. Notice our choices. We have 0.25 as either 250 or 25 million. So as you move your decimals appropriately, you're going to have to move it enough times to get your 25 million as the answer choice. So when we were working with polynomials and monomials, we had many definitions. One to keep in mind, the degree of the monomial is the sum of the exponents of the variables. The coefficient is the number in front of your variables, and a constant has degree 0. If you're in standard form, the terms are listed by degree, greatest to least from left to right. And the degree of the polynomial is the greatest degree of all the terms. Your lead coefficient is the coefficient of your lead term. When you simplify a polynomial, make certain that you follow what you're being asked to do. So the first question, number 2, you're being asked to add. The next question, number 3, you're told to subtract. When we subtract, make certain that you distribute that negative to each of the terms. So we'll have a negative 3x squared plus 3x plus 2. You can only add your like terms. So when we add, we get 1x squared plus x plus 9. So as you look at this problem, notice that the lead coefficient is equal to 1, that the degree of this polynomial is 2, and that this is in particular a trinomial because it has the sum of 3 monomials. For question 4, you have Darnell and Stephanie competing for the refreshment stand businesses. We have Darnell's model and we have Stephanie's model. Write a polynomial expression for the difference between these models. So the difference between Stephanie's profit and Darnell's profit. So what we want to do is take Stephanie's model minus Darnell's model. So make certain you get your minus signs in the right place. Write your expression. So we'll have this minus RC squared plus 8C minus 100. Then you simplify the same way we did number 3. We want to write a polynomial. So what that means is we want this simplified expression for when we decide to, if we expect them to combine their terms. So that means this model will be Stephanie's plus Darnell's. And when you write your polynomial, make certain it's in standard form. We worked with distributive property. And for the distributive property, we would distribute the variable to the terms inside a binomial. So let's look at our first number, number 5. We're going to take negative 3x to the negative 3y to the 4th and multiply it by each term in this trinomial. So then we'll have negative 3x to the negative 3y to the 4th times our negative 3x cubed. And lastly, negative 3x to the negative 3y to the 4th times 2xy to the 6th. Afterwards, we want to simplify. Negative 3 times 2 is 6. The y to the 4th is in the numerator divided by x to the 3rd. The reason x to the 3rd moved to the denominator is it had a negative exponent. Remember, x to the negative 3 times x to the 3rd is x to the 0. That's 1. So for our second term, we're left with negative 9y to the 4th. Lastly, 3 times 2 is 6. We have y to the 10th in the numerator. And, oh, look at this. Negative 3 plus 1 is negative 2, so we're going to have x squared in your denominator. For division, you're going to distribute 8x to the 4th over 2x cubed minus 4x to the 3rd over 2x cubed plus 2x over 2x cubed plus 1 over 2x cubed. All right, simplify. We have a 4x minus, oh, came out to be 2. The next term is plus 1 over x. Lastly, plus 1 over 2x cubed. Okay, so when you multiply a binomial times a binomial, take your x, multiply by 6x. Here we have 6x squared. X times 1 plus x. Okay, look at this. Negative 2 times 6, negative 12x. And then we have a negative 2. We will add our like terms, x squared minus 11x minus 2. Notice this is a trinomial, degree 2, with a lead coefficient of 6. Here's a sneaky one. This one, we're going to combine our multiplication with our exponent rules. So it's a lovely problem. Write a minus 2 times a minus 2. Then we're going to use that distributive property to get a squared minus 2a minus 2a, and a negative times a negative is positive. So we get a squared minus 4a plus 4. Now don't do anything silly with this problem. Do not do a squared and 2 squared. That type of problem only works if we have multiplication. But this has a negative sign, which means it's a binomial times a binomial problem.